The following is question 16 on exercise 4.4. The size, the mean and standard deviation, 3 different data sets are given in the table below. Alright, where n is how many objects are they tested, so 62, 203, 11. The mean of P is 10, the mean of Q is 5, the mean of R is 4. Standard deviation of 9, standard deviation of 3, standard deviation of 0. The biggest set is the set with the biggest n value. The biggest set is Q, and the smallest set is R, because R has 11 and Q has 203. In general, the data in sets, P is the biggest because it has the biggest mean. Biggest mean means it's the biggest. The data in set P is the most spread out. The one that has the largest standard deviation is the most spread out, okay? So that's data in set P are more spread out than the data in the other sets. List the elements in set R. Now set R has 11 of them, but there's no standard deviation. That means it's basically 11 fours. If there's no standard deviation, it means that none of them drift away from the mean. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is the data of part 4. Okay? Now number 5. If sets P and R are combined, what is the mode most likely to be? Okay? Now let's have a look at this, okay? First of all, P has 62 numbers, R has 11 numbers. This makes it 73 numbers, okay? Now, 73 numbers, and you're looking at the mean of P was 10. I wouldn't imagine P has many 4s in it, would you? If the mean is 10, the likelihood of it having over 11 4s is very, very slim. Because basically, it could happen, but because the average is over 10, you're going to have a lot of numbers that are over 10. Therefore, your 11 4s are part of the 73 numbers now, aren't they? Because I combined the answers of both sets together. This means that the mode is most likely to be the number 4, because we know there's 11 of them in there. Okay? When we join both sets of answers together. Very unlikely to be asked something like that. Okay? Now, next one. The masses of a group of students were found to be approximately normal. Now, see this word normal, please, when you're in a test, normal. When you see normal, this means that the deviation rule stands. So x plus or minus the standard deviation gets 68% of everybody. X plus or minus 2 standard deviations gets 95% of everybody. And x plus or minus 3 standard deviations gets 99.7% of everybody. That's what you need to know off by heart. It's not anywhere in your tables. So the minute you see normal, mean and standard deviation, that should come to your mind. Now, what we're going to do is you'll notice that it's cut into 3 parts. So this is going to be -1, R is -1 standard deviation, okay? P is the mean, it's dead center. So what's the mean? So what would P be? P is going to be 62 kilograms because it's dead center. Number 2 is Q. Q has to be a bigger number than P because it's to the right of it. It's 2 standard deviations. 1, 2. 2 standard deviations to the right. So it's going to be 62 plus 2 times 6, which is going to give you 74 kilos. So that's what PQ is. R is 1 standard deviation below 62, so it's going to be 62 minus the standard deviation, which is 6, which is 56 kilos. It has to be below 62. And S, which is going to be smaller than R again, is 3 standard deviations, 1, 2, 3 below P. So it's going to be 62 minus 3 times 6. So that's 62 minus 18, which is 44 kilos. Okay. To go still nails are produced so that their length is normally distributed. Once again, that word normally distributed means like the 95 to 68% and the 99.7% are in play, with a mean of 4.27. So the mean is 4.25 is dead center. 95% is plus or minus 2 standard deviations. So 2 standard deviations down is going to be 4.2705, and 2 standard deviations up is going to be 4.2925. So the easiest way to do it is to say, well, the gap between the two of these is 2 standard deviations. So we can say is 2 standard deviations equals 4.25 minus 4.2075. What do you get when you take them away?
0.0425.
0.0425. Then divide that answer by 2 to get 1 standard deviation on its own. So when you divide it by 2, Harry?
0.02125.
0.0125. Okay. Now, another way they could ask you this would be, imagine they never gave you the mean. Imagine they said the mean, they just gave you the top and bottom values. How would you find the mean then? If I was to ask you, first of all, how would you find the mean? It's dead center, isn't it? So if you add them both together and divide by
2.
So add them both together and divide by 2. If you're asked to find the mean and they only gave you what the 2 standard deviations below and 2 standard deviations above the mean was, how would you actually find the mean? And what you get?
8.5.
Say?
8.5.
Divided by 2.
Oh.
4.25. That's the way you could find the mean if they only gave you those 2 items of information. Now another way of doing it would be, the gap from here to here would be 4 standard deviations. Okay? So what we could do then is we could say, alright, 4 standard deviations is the same thing as 4 standard deviations is the same thing as 4.2925 minus 4.2075. What's the 2 of them take away from each other? 0.85. Divide that by 4, and what you should get is what we got for the last question. 0.02125, right? Exact same answer, both ways.